Welcome back, math enthusiasts. Today, we have a fascinating optimization problem involving three positive variables x, y, and z. We are given the condition that the product of x, y, z times the sum of x plus y plus z is greater than or equal to 1. Our goal is to find the minimum value of the expression x plus 2, y plus 3z. Before we dive into the solution, let me remind you of the powerful AMGM inequality, which states that for any non-negative real numbers, the arithmetic mean is always greater than or equal to the geometric mean. This inequality will play a crucial role in our solution strategy. Let's start by testing some values of x, y, and z to get a feel for the problem. First, try x equals 1, y equals 1, and z equals 1. We get that the product of x, y, z times the sum of x, y, and z is 3, which is greater than or equal to 1. Thus, the inequality holds, and the value of x plus 2, y plus 3z is 6. Now, let's try different values like x equals 3, y equals 1/2, and z equals 1/3. The inequality becomes the product of 3, 1/2, and 1/3 times the sum of 3 plus 1/2 plus 1/3, which is greater than 1. And the value of x plus 2, y plus 3z is 5. So, we've lowered the value from 6 to 5. Can we minimize it even further? Now, let's formalize our approach using the AMGM inequality to find a lower bound. We want to minimize x plus 2, y plus 3z, and we already know from our earlier trials that we can get close to the answer. But here's where the AMGM inequality comes into play. We can write x plus 2, y plus 3z as a combination of weighted sums. For example, px plus qy plus rz plus s times the sum of x plus y plus z, where p plus s equals 1, q plus s equals 2, and r plus s equals 3. Now, applying the AMGM inequality to each of these terms gives us a way to estimate a lower bound. Additionally, we can also use the condition that the product of x, y, z times the sum of x plus y plus z is greater than or equal to 1. This condition helps us further bound the values of x, y, and z. Together, these two tools will give us a sharper lower bound for x plus 2, y plus 3z. Finally, let's put everything together and derive the solution. We begin by expressing x plus 2, y plus 3z in terms of weighted sums, taking inspiration from the previous slide. Using the AMGM inequality, we know that the expression is minimized when the terms are balanced in a specific way. We can rewrite x plus 2, y plus 3z as a combination of certain weighted sums, where we distribute the values of x, y, and z in such a way that we apply the AMGM inequality effectively. Using the condition that the product of x, y, z times the sum of x plus y plus z is greater than or equal to 1. We estimate that x plus 2, y plus 3z is greater than or equal to 4. In fact, we find that equality holds when x, y, and z take specific values. Therefore, the minimum value of x plus 2, y plus 3z is 4, achieved when these specific values of x, y, and z hold. Thank you for watching, and don't forget to like, subscribe, and share this video with others who love math problems as much as we do. See you next time.